Nebraska on Tap, the source for everything educational and informational about groundwater in agriculture. If you are an ag producer or a citizen of Nebraska, this show is made for you by the Middle Republican Natural Resource District.
Now it's time for our weekly show, hosted by Heather Disming.
Hello, everybody. Thank you so much for joining us this week. So this week our show is going to be about AEM. So AEM stands for Airborne Electromagnetic Surveys. The S is silent. Anyway, this creates a continuous image that is interpreted for underground geology. We brought on Jared Abram, who is from Aqua Geo Frameworks, and then we also brought on our engineer for the Middle Republican, Alex Boyce, and I had them sit and kind of have a soft conversation about some of the things AEM involves. If we were to get into it, I mean, we could be on the phone with Jared for like 3 hours, and he just has a lot of information to give. So the use of the AEM technology to map and evaluate underground resources has gained momentum over the last 20 years. The state of Nebraska has been the forefront of implementing AEM in the United States for water resource management over the last decade, with projects across the state in a variety of geological settings. The western portions of Nebraska utilized AEM surveys, the North Platte NRD, the South Platte NRD. They began in 2008 under the USGS guidance, and then that continued into 2010. The Twin Platte started doing it, and then we started doing it in 2016. And then data from all of these NRDs have been used in several research projects by others. Mostly by the University of Nebraska-Lincoln. Once these AEM surveys are done, all this information is sent off to get a model built. So it takes a lot of dedication and it takes a lot of people to really make the focus of getting these underground geological surveys done. So let's get into that interview that I had with Alex and Jared so you guys can be a little bit more informed on all the great stuff that these AEM surveys do have and some of the limitations on these AEM surveys currently.
Hello, my name is Jared Abraham, principal geologist, geophysicist with Aqua Geo Frameworks, a company that specializes in using airborne geophysical tools to map hydrogeologic frameworks. We're based in Fort Laramie, Wyoming, with offices in Georgetown, Colorado. We've had the wonderful opportunity to work extensively in the state of Nebraska and over several projects with the Middle Republican Natural Resource District.
I'm Alex Boyce, and I'm the engineer here at the Middle Republican NRD. Got a background in environmental engineering and just kind of expanding the technology here at the Middle Republican NRD, and AEM's kind of been part of that expansion of technology.
Yeah, so I was reading through the grant, Jared, and it seems like you guys have been out here once before, correct?
We did two projects. One was with a partnership with Twin Platte Natural Resource District, where we flew a little bit into the Middle Republican associated with the InCorp facility. The airborne AEM data has been used before in looking at enhancing groundwater models that it was in the North Platte Natural Resource District up around Scotts Bluff. And that project was done with the USGS. And one of the big benefits of it was coming to just the structure of the bedrock. It was a very paleo-channel dominated system. Later, the Lower Elkhorn Natural Resource District took their extensive coverage in a glaciated area of Nebraska and actually started building a groundwater model that the Nebraska Department of Natural Resources has endorsed and is accepted as a active management tool. Many of the districts out east are just beginning a large groundwater model based on the airborne EM. We feel very confident that the Middle Republicans ultimate product will be a successful one and one that they can use for groundwater management for many years in the future.
That's what we hope for too.
Yeah, that's my expectation.
We did kind of a kickoff demonstration or a focus project in 2020 with the district. And that was in some of the western areas, kind of along the river corridor. And we had great results. We also worked with the University of Nebraska-Lincoln, Jesse Course, professor in charge, and his students on that part of the project. And I think all of us were extremely excited with the results. Not only could we see the bedrock configuration, we saw a lot of details within the Ogallala that had really profound insights in the complicated nature of the channel deposits in the Ogallala, tertiary Ogallala, which is a formation that really consists of most of your aquifers in the area. And what makes it incredibly complex to look at is it's a stream system, and we use the term anastomosing. It's kind of a complicated term saying it's meandering back and forth, and there's channels cutting across channels, and where the best aquifer is where those channels are. And what is really critical is if you're on one of those channels, and in the center of one of the channels, your well and your ability to produce from the aquifer is not as impacted from any type of decline as if you're on the edges. And think of it as a bathtub or a kitchen sink that's curved on the edges. If you're in the middle and you drain your sink out, that water's going to stay in the middle. But on the edges, that's where things are critical. So I believe what really helped kind of spur where we are now with the district is that demonstration showing we can really see those channel configurations and where there are good aquifer materials, meaning sands and gravels, sandstones, versus the silts and clays.
What made you want to do that area first, Alex?
Well, that's our area we're seeing the biggest declines in aquifer. So we figured that would be a perfect opportunity to try this stuff. And I think everyone from the board saw that and they're like, man, we really need to go all the way in on this and then develop it even further with the groundwater model. So I think, I have pretty much once a week, I have somebody come in and say they drilled a well and it's not pumping near what the old one was. And just having this type of information has been really useful for us so far. And I think it'll only get more useful in the future when we're all said and done with this. So we're kind of expanding down towards kind of by McCook and stuff along the Republican River Basin because we're seeing some more problems down there. And it's just handy to have a full picture, I guess.
And is that kind of what you guys mainly do when you come into main areas first and then expand out from there, Jared?
Yeah, that's been the approach mostly in Nebraska and in North Dakota and California. It's kind of our primary areas. We've been doing a lot of flying. This stuff is it's not free. It's not cheap. You look at it per acre, it had some incredible benefits. But you really have to focus on an area that has a need. And, resources are limited. So the way we've tackled this and in the grants working with Middle Republican and other districts in Nebraska, say, okay, where is there a critical need where the boreholes alone are not providing an adequate framework to get a handle on what's going on so the board can make decisions. Do we need to cut allocations? Do they need to cut back wells? Do they need to be, replacement strategies, all these management things? And the boards are saying, we don't know which way to go. Because, as Alex said, one borehole is great. You go a half a mile, 2 miles down the road, you have another borehole that's terrible. And so focusing in on an area that gives trust in the results and maybe illuminates the usefulness of it, and then expanding out to other areas, using the core demonstration area as really the foundation to build on. And we do a strategy where we vary our line spacing or how close we fly based on kind of the spatial needs. So if this is an area that has kind of a very limited aquifer, we wouldn't need to cover it at such detail as an area that's much more densely covered by a good aquifer, one of these channel systems I was telling you about. There we'll do finer lines and really try to go over key wells and key structures that have been mapped with previous work. One of the most important things in looking at this technology, it's amazing. You get these amazing pictures of the Earth, but it doesn't replace classic geology, hydrology. What it does is it takes all the work that's been done previously and starts laying in this framework. So, that's why, the well in the northern part of this area performed poorly. It's off the paleo channel. So that's kind of how we've done this throughout Nebraska. We've flown most of the glaciated areas in eastern Nebraska, and we started with small focus areas where there were problems with water resource management, and then expanding out to cover most of the district's aquifer systems.
When it comes to this data, Alex, how has that helped you with the well locations for people who are asking about re-drilling?
The information we go off now is basically a 6-inch hole every, could be every quarter mile from all the way up to, 10 miles away. I don't know how often the AEM takes a measurement, but it's much closer than that when you fly on a straight line. So you can you're able to connect those dots a lot better. Like he said, it can vary so widely from, within a quarter of a mile of where you're trying to drill a well. So just having, and I always tell them it's not exact right now because we haven't calibrated to what our boreholes and stuff. It's just pure resistance is what I'm giving them. But just having some sort of insight of, they can see we drilled a well here. It doesn't look like it's very good. Where should we try? And so I say, well, clearly this area is a little better. If you moved another quarter of a mile, you'd be a lot better off. So
also, Jared, with you being in a little bit more of a drier climate in Wyoming, have you guys ever flown over that area as well?
Absolutely. We've done quite a bit of work in Wyoming. We have an active project right now with the city of Cheyenne in doing a well field expansion project, working with WSP USA. Same environment, the Ogallala Aquifer, sitting on Cretaceous and tertiary bedrock. Same sort of thing. They have wells, they've got mapping that's been done historically, but they need a finer increment. And they've taken it one step farther and where the district's going is a groundwater model. So now the board in Cheyenne can actually do tests. If we do augmentation or recharge in this area, and we have another drought year, is that going to provide us a buffer in our well field? And how do we manage our well field? Do we produce out of, the northern well field heavier than the southern, depending on the situation? So they've been very thrilled with the project. We've also done work for the city of Laramie, again, looking at aquifer protection. And again, a lot of the aquifer materials are very similar. We've also done several projects along the South Platte River in Colorado. Same sort of questions and same type of aquifer materials. Where do they manage these areas? Is there room for more wells? Will that damage the resource? What's the limit of the resource?
Yeah, and then also just going on that, when it comes to recharging the aquifer, Alex, have you felt like this information has definitely opened up your eyes to a few areas that we could definitely be utilizing that recharge?
It's kind of early to tell that right now, but it will in the end. This gives us a starting location, I guess, until you have a full groundwater model. And I think we already know that closer to the aquifer, the quicker the impacts. I think there still needs to be some research and some thinking done about what a good recharge location would look like.
And so in similar types of environments, recharges come up over and over again. And one of the things you're looking at is there a pathway to the aquifer from the surface or using injection wells, et cetera? One of the things, the data that can be very valuable on is when looking at areas where there's thin silt and loam and lush cover, which would preclude infiltration from surface recharge. And so you can eliminate a lot of areas right away. Then you can start looking at property access, agreements that could be fostered there. The next stage, you go in and do some infiltration tests, actually active tests on the ground. What the framework can do is really limit those areas to key places. So you're not just shotgunning the whole area where you go out and say, oh, well, there's 20 feet of lots and clay. This is a terrible recharge area. So that's how it's been used before. And I can see in certain environments in the Middle Republican, that will be a good way to use that. The other thing is where are you going to get the water to recharge from? And usually that has some access to a surface water source. So those are some of the other important criteria beyond just the geology of stuff and utilizing a recharge situation.
I mean, it's nice, though, that the Republican River has been up a little bit more since it was last year, especially when we got, how many inches of rain was that?
Like 6.
Yeah, all at one day. So, I mean, that's great to see that. So hopefully we can understand that a little bit better after we go out and test those things, that it does transmit those radio signals back from the ground, that it gets sent out. Okay.
So let me tell you a little bit about the system. This is what's called Airborne Electromagnetics. Electromagnetics is related to how the signals propagate from the system. It's using the concept of induction. So what's wonderful about induction, you're creating a signal from this loop that's going into the ground and diffusing, a bit like a smoke ring. And you don't have to touch the ground. You have no need for coupling. So it's very similar to, inductive surface, stoves that we see in kitchens where, the burner's not on the surface. It's under glass and it's being inducted into the metal pan. Same sort of physics going on. Well, what this allows us to do is we fly the system that's a little over 100 feet in diameter and over the earth, 100 feet above the earth, sees down, and it's sensitive in the area of the Middle Republican of about 1,500 feet. So well into the aquifer. As we fly along, we're flying at approximately 50 miles an hour. It depends on the topography and stuff. As we're flying across, we're trying to keep it exactly at 100 feet. High trees, we go a little higher. We have to avoid farmhouses, infrastructure, power lines, all those things you don't want to fly over. They cause interference, and we can't fly over any structures due to FAA regulations. So what comes out of that, we get a data point every 100 to 300 feet. So after acquisition, we'll take the data, which is just voltages with time. Well, if I were to deliver this to Alex, he'd be like, Jared, what am I supposed to do with this? It's absolutely meaningless at some point. So what we do is we create something called an inversion. We're saying, okay, if we flew over an Earth and we saw this signal, what would the Earth have to look like? So we're inverting our observed data, which is voltages of time, and reconstructing what the Earth is. And this would be resistivity with depth. Now, resistivity is the resistances of materials to conduct electrical signals. So what's good for us is clays and silts are electrically conductive. Sands and gravels with fresh water in them are electrically resisting. Well, that's exactly what we want to see in the aquifer space. We're looking for the sands and gravels full of clean water, fresh water. So we basically take those voltages with time and construct resistivity with depth. And that's our first kind of view of the Earth. Later, we translate that using the boreholes in the area to material types with depth. So this would be clays, shales, limestones, sandstones, sands, gravels, silts, clays, lusts. And that's where we go from this voltage of the depth to actually something that hydrologists can use to understand what's going on. And Alex can use to say, hey, you know, what we've seen here is there's a paleo channel system. If you were to go a mile to the north, you could go, you know, maybe 200 feet deep and see the aquifer. Where if you're in a different area, maybe the aquifer's only, you know, 20, 30 feet thick. So a much more limited resource.
Yeah, well, I can tell you that when you guys flew over, everybody had you as a spotlight on Snapchat. All the farmers were definitely excited to see that helicopter come through their area because they know that later on that they can utilize that data that you guys have collected to help them find something or better, you know, utilize their resources in the future, which I think is great.
Yeah, and I think there's kind of a misconception too, because I've had, you know, producers come in and say, oh, you're checking groundwater levels with that thing, aren't you? And I said, not quite. It's a little more in depth than that.
So one of the questions that comes up a lot is, can you guys see the water table?
Mm-hmm.
Well, the answer to that is some places we can. It really involves the water quality. If it's very saline water, poor water quality, it shows up very well. Luckily for the Middle Republican, there's very little water quality issues in regard to salinity and such. So it's much harder area of the Middle Republican because so many variations exist within the materials of the aquifer. So the clays and the shales are interspersed. We have silts layers and such. And so trying to decouple that small change in resistivity from saturated aquifer materials to unsaturated is challenging. What we do see that shows up really well is like aeolian or dune sands on the surface that are dry. Those are very electrically resistive, and those really show up as dry materials. Areas where we've been able to map the water table very successfully are areas in the Mojave Desert, California, where it's all this very clean sand, and the water table, you go from something that's in 1,000 ohm meters down to 20 ohm meters when you add the water to it. So that's been successful. For the Middle Republican and much of Nebraska, we see signs of the saturation in some areas, but we've typically always relied on the well sampling in the area to give us that real concrete ground truth of this is where we've observed the water table, and overlaying that on the airborne framework to get a more stable result or a more confident result on the resistivity with that.
Mm-hmm.
Right. And that makes sense. So then you know that your data is adding up because you have two levels of it.
Exactly. One thing with the airborne, and we do this a lot, and it's incredible what it can see, and you guys have both seen that in some of the products. But it's not magic, and it's still a little blurry, right? It's about looking at, you know, things through frosted glass. And when I tell that to people, I say, oh, well, it has some real limitations. Well, it does have limitations, but it provides us so much more than just drilling alone. And again, the thing that really is important is it allows a confident connection between our boreholes, our control points. So what's happening in between? Is there a bedrock high or not? Is there still this oxygen material where, even though this is blurry, we can still see some things? Because you think about a little bit what we're doing. We're flying a sensor 100 feet off the surface of the Earth at 50 miles per hour, and we're seeing down 1,500 feet. And we're doing that 10 times a second and getting a data point between 100 and 300 feet along the survey line. So that's a lot.
Yeah, that's definitely a lot.
And unfortunately, in physics, it's not magical. If it was magical, it would be so much easier. I could just hit a button and say, there you go. It's perfect to within, you know, fractions of an inch. And so this is one part of the tool to build the framework. And one of the things we've seen throughout Nebraska and other surveys, that when you have this data, it moves the discussion away from coulds and maybes to, okay, this is what we have. How can we manage this resource effectively? And how can we preserve or come up with a sustainable management? So it really moves the conversation away from coulds and shoulds and maybes to, this is what we have, let's move forward.
No, I agree with that, and then this plus our meter program and other things that we're trying to do to help conserve below us here, is hopefully our aim is to really make it pay off. And I think we're on the right track. Anything else?
For us at AGF, we're very grateful to be working with you guys. And what's very rewarding to us is it's not just a study that's going to sit on the shelf. The efforts from our air crews, maintenance crews, helicopter pilots to, the GIS people putting this together, all this for you, you're going to use it. And you're going to use it in a way to enhance the management of your district. So that's extremely rewarding for us.
Yeah.
Anything else you want to add, Alex?
Well, I guess the finished product of this, we are going to make a full 3D map of our entire district. And then we're developing a groundwater model the traditional way right now. And whenever we have this 3D map, it'll actually give us aquifer properties that we can plug directly into a model. So we'll be able to compare exactly what the difference is between the standard traditional way of developing a groundwater model to having this full AEM study done. And I think that'll be really interesting to see, if there is a major benefit in seeing through the frosted glass, I guess.
Yeah. And well, Jared, we are just so grateful for your partnership on this with Aqua Geo Frameworks, just because you are so knowledgeable and you've been such a great partner in all of this geomapping and the AEM surveys and stuff like that. So we really want to thank you for everything that you've done.
Great. I really appreciate. I want to thank the board and the people of the Middle Republican Natural Resources District for having trust in us to provide a product that will live for many, many years.
Yeah, and I'm excited about it. I know the producers are excited about it, and hopefully the municipal water will be also happy about it. Thank you again for your time, Jared. We appreciate it. You're just so knowledgeable.
Easy. Thanks again, you guys.
Yeah. Hopefully you guys gained a lot of knowledge out of that interview, because wow, I didn't even know about meandering bedrock, but now I do. So next time you're needing anything from Alex, just know to be patient, because this is a huge process with the AEM. And so even though it was really cool to see all of the helicopter action with the big hoop and everything, that these projects just take a little time, but once the time's been put in, they're going to be so beneficial. So we thank you guys again today for listening to our podcast here with Jared from AEM and Alex, our engineer here at the Middle Republican. Have a beautiful day, and we will talk to you later.